All right, let's just jump right in. We are absolutely swimming in information these days, but how much of it is actually real, solid knowledge? Today, we're going to pull back the curtain on the hidden rules that separate science you can trust from stories that just sound good.
You know, Richard Feynman, one of the most brilliant physicists ever, said it best. He was always warning people about this. He knew that without a really strict set of rules, it is just way too easy to fool yourself with something that looks like science. He especially thought fields like the social sciences needed to be extra rigorous to produce anything valuable.
So that really brings us to the big question for all of us, right? How in the world do you separate the signal from all that noise? Well, the answer isn't about becoming an expert in everything. It's about understanding the hidden rules of the game, the methodology that tells you whether a claim is actually credible.
And that's where the social sciences come in, because they study the messy, unpredictable world of, well, us, of human beings. For the longest time, these fields were kind of looking over at physics, with all its clean laws and equations, and had a serious case of what some called physics envy.
See, there was this tension. At first, there was a huge enthusiastic push for better, more rigorous methods. But after a while, that started to fade. The methods section of a paper was seen as, the boring details. The real prize was selling a good story, where the narrative, the big takeaway, was way more important than the nitty-gritty of how you got there.
But fast forward to today, and everything's changed. We turn on the news and see experts waving graphs around, debating data, and all of a sudden, we're all realizing that those boring details, like how they measured something or where the data came from, well, they're not boring at all. They're literally everything. They're the difference between truth and misinformation.
So how do we even get here? Well, the history of how we do research isn't some dry list of rules in a textbook. It's actually a pretty dynamic century-long story about a whole field of science trying to find its footing and learning, step by step, how to ask better and better questions.
You can actually map this whole journey across 6 distinct eras. And what's wild is how much the focus has shifted over the past 100 years. It went from the very basic question of who are you with things like the first personality tests, all the way to the super complex, multi-layered approach we have today.
In the very beginning, it was all about pure discovery. Researchers were just exploring. They were using tools like case studies, creating the first tests to measure things like intelligence. But as the field grew up, the focus made a huge pivot. It went from just exploring to actually verifying, testing specific ideas, and trying to build on what we thought we already knew.
Then came the mid-century, and it was marked by this total obsession with measurement. But pretty quickly, that obsession was followed by this period of, discontent, as researchers started realizing that their shiny new tools were actually pretty flawed. And that crisis is what sparked the invention of really powerful new ways to analyze data, like meta-analysis, which is a way of combining the results from tons of different studies to see the bigger picture.
And that brings us to the modern era, which is really defined by this idea of from one to many. Researchers finally, collectively threw up their hands and said, okay, no single method is a silver bullet. And that realization led to this incredible explosion of different approaches, using multiple sources of data, and setting people over longer periods of time to get a much richer, more complete picture.
Okay, so what's actually in a researcher's toolkit today? If you boil it all down, it's really split into 2 main ways of looking at the world. Each one has its own philosophy, its own questions, and its own set of tools.
On one side, you've got quantitative research. Think numbers. This is all about asking how many or how much. It's trying to find big, broad patterns that apply to lots of people. Then on the other side, you have qualitative research. This is the why or the how. It dives really deep into specific situations to understand the meaning and the experience behind the numbers.
Now, what's really interesting is when you peek behind the curtain at what quantitative researchers are actually arguing about. An almost equal amount of their energy goes into 2 things: perfecting their measurement tools and debating the absolute best ways to analyze the numbers they collect. The actual design of the study gets way less attention in their academic debates. And what that means in the real world is that the most common ways they gather all that data are through good old-fashioned surveys and what are called longitudinal studies, which just means tracking the same people over time to see what changes. Now, compare that to the qualitative world. It's almost the exact opposite. Here, the big conversation, more than half of it, is all about the study design itself.
They're way more focused on the overall approach and the philosophy of how to interpret what they're seeing, and much less on the specific measurement tools.
So all of this history, all of these methods, it brings us right to this moment. Because right now, the entire system is being put to the test. Science is facing some really critical challenges that are going to decide whether we, the public, can actually trust it in the future.
Right now, researchers are trying to clear 5 major hurdles to keep science trustworthy. These are big deals, ranging from how we double-check old findings to how we even come up with new ideas in the first place. Let's dig into a few of the most important ones.
Okay, first up, replication. Basically, this just means independently checking someone else's work to see if you get the same result. It's supposed to be the absolute bedrock of science. But in a lot of fields, the pressure is always to be new, to be novel. So foundational findings almost never get retested. We just keep building on top of them, hoping the ground beneath us is solid.
And what about studying the exceptions? Our methods are amazing at finding the average of a big group. But think about it. If you want to understand how the Oakland A's baseball team won so much with a tiny budget, you have to study them, the exception. Same for a tragic Amtrak accident. If we only ever study the average, we become a science of the mean, and we miss all the crucial lessons from the best and the worst cases.
And get a load of this. Modern statistics software is so powerful and easy to use that it's also incredibly easy to misuse. One study looked at papers in top journals and found that almost 40% of them that used a common analysis method reported incorrect values. That means they weren't even testing the theories they claimed they were testing.
This kind of thing can lead to a really bad habit called harking. It stands for hypothesizing after the results are known. It's basically when a researcher finds a surprising result in their data and then goes back and rewrites the introduction of their paper to make it seem like they predicted it all along. It's telling a story backwards, and it completely erodes trust. And the best way to fight it is just to focus on really good, thoughtful research design from the get-go.
So after this whole century-long journey, what's the big takeaway? It's that the search for knowledge you can actually trust, well, it's not about finding that one single perfect method that's going to solve everything.
It's really about the constant, critical, and, yeah, sometimes pretty messy evolution of the rules themselves. The fact that scientists are arguing about this stuff, that they're challenging old ideas and developing new methods, that isn't a sign of weakness. That's the sign of a healthy, self-correcting science that's genuinely trying to get to the truth.
And that leaves us with this one final, kind of mind-bending question to chew on. If the very rules we use to define what is true are always changing, how do we ever really know if we're getting any closer?